Okay, I guess I can start. And good morning from North America. It's 4 a.m. here. Very good time for conference. Thank you for hosting us online. I regret that we couldn't attend in person to see and meet you face to face, but I'm very grateful to organizers for opportunity to present our paper. As you can see from our ambitious title, we aim to use OpenSky ADS-B data to develop a model predicting future geopolitical conflicts. Next slide, please. This idea originated from previous research where we analyzed OpenSky ADS-B messages, focusing on missing and unrealistic GPS coordinates. We termed these GPS gaps for missing coordinates in an aircraft's route and GPS jumps for unrealistic coordinates. We then found a correlation between a high number of GPS anomalies in ADS-B messages in air traffic levels in specific areas. However, our analysis identified certain regions that did not follow this pattern. In areas around Moscow, Israel's border, Iran, India, Afghanistan border, and other regions, GPS anomalies were more frequent than even when air traffic was relatively low. These regions are known for significant geopolitical events or military activities. And in this paper, we aimed to further investigate this finding. Next slide, please. First objective examines whether GNSS anomalies can reliably indicate areas at risk of geopolitical instability to see if they can serve as early warning signs of conflict. Second objective focuses on creating and testing models to predict areas with rising conflict risks using ADS-B data patterns. Next slide. Two main sources used in this paper are, first is OpenSky Network Trino database of ADS-B messages, and second, ACLED database of armed conflicts. We used the dataset created from the OpenSky network data. It included air traffic per half by half degree area per hour. It also included GPS anomalies, jumps, and gaps. We aggregated the data per day and joined with daily ACLED events. Our model used GPS gaps density and GPS jump density in relation to the ACLED events that happened in the same area, same day. Next slide. We used ArcGIS software to visualize the source data flights by grid. Next slide. We used ArcGIS software to visualize source data ACLED counts by hex pin. My co-author, Ibrahim Kokeman, will continue. Next slide. Yeah, it seems there is a technical issue with Ibrahim's connections, so I will try to cover for him. For this slide, for method, in prior research, Poisson regression was used that was for count data, and our data is coded as 1, 0. So the logistic model is appropriate here. X was done 4 times, counts of gaps, jumps, then density of gaps, and finally density of jumps. Next slide, please. The first equation was on the whole data set, and while it had an accuracy score of 99.99%, but it was not truly predicting correctly. Rather, this was caused from an imbalance of data. it meaning over 100 zero data points for each ones of data. After removing outliers, one second. After removing outliers, the accuracy score reduced to around 60%, but the model was predicting correctly after redoing on balanced data subsets. The coefficients and the overall performance of the model showed stability. Next slide, please. We ran several models, and we used the predictor variables of GNSS jumps. So we achieved a little bit higher accuracy score. And I would really need Ibrahim to cover this slide, but what I can tell here that bottom line of this research is as a previous speaker said that there is data, or there are data that we are usually trying to filter out because the data it may be errors. In this research, we are trying to use that data, the data that looks abnormal, and we are getting some results. So mathematical statistical analysis shows that we are on the right path. It will take time and effort, and obviously there are limitations. So next slide, please.
That's all.
Those are references. I'm sure that you would have like million of questions, and I'm ready to answer.
If people can hear me, I can add some context to the previous slides.
Yes, please go ahead, Ibrahim.
So if you can hear me, people can hear me as well. Can you go back to the previous slide, please? All right, sorry about that. I tried to change my microphone settings. So we basically, as actually Eugene did a good job of explaining our models, we basically ran a binomial regression, and since our outcome variable is a dichotomous variable for the grid cells where it's 1 for the grid cells where we have an acolyte event, a conflict event, and 0 for the ones that we didn't have. So that's why we run a logistic regression. Like you mentioned, we ran several models, and when the best performance model convergence we get was with the jump densities, which actually makes sense because jump densities is basically normalized data, not just counts or of the GPS gaps or jumps, but densities. So what our regression analysis shows us is there might be an association between GPS gaps and jumps and conflict events. So we based on using the existing studies and our expertise, we tried to come up with potential explanations as to why this association might be happening. One explanation is potential electronic warfare activity, like GPS jamming and spoofing, which is actually shown by previous research. These could be used by either state or non-state actors. Other increasingly relevant activity type of disturbances are cyber espionage or cyber attacks, because these type of attacks or sabotaging events on infrastructure might be actually a preliminary step for conflict escalation. There's also intelligence gathering activities, airborne intelligence activities like intelligence-related flights might also be causing anomalies in GPS data, and that could all at the same time might indicate preparations for conflict. So these were some of the explanations we were able to come up with as to why this association might be happening. I'll be happy to answer if you have any specific questions.
Okay, thank you very much. Are there any questions from the audience here in the room? There's one online question. Let's go for that one. How can you identify which GPS data are anomalies due to electronic warfare or due to other reasons?
Eugene, do you want me to?
Yes, please go ahead.
At this time, we don't have a method in distinguishing between jamming-related GPS anomalies and the other ones.
Ivan can add to that because we don't actually know if the GPS problem that we see, it's actually a GPS problem. It may be a DSB problem, right? It's supposed to be not, because we only analyze ADSB data when we see a perfect ADSB package that missing GPS coordinates or has some wrong GPS coordinates. So ideally, it shouldn't be ADSB data, but we don't have any proof. So we don't have proof if the error happens on the GPS level or ADSB level. But what can we say that if there are errors, right, GPS or ADSB, that means either something wrong with the equipment, right, that receives or transmits, or there is something in the environment, like spoofing or jamming. And when we see a large amount of those errors, it's more likely that it's not the equipment, because at least it's not from the specific aircraft, because we see it on a number of different aircrafts. So I hope that helps.
Thank you very much. Further questions? Yeah. Good to see you again.
Thank you very much for your talk. You have shown that you can see a correlation.
I also can add about limitations, because
LED data, but you want to do a prediction. So I wonder if I want to know, is there a conflict coming up? You know, I can just look in the ACLED data. I can see, okay, there is a conflict. But have you shown in retrospective that the GPS jamming or spoofing is before you actually see that in the ACLED database, you see the conflict? That would be a real prediction.
Excellent question, and that's exactly what we are trying to do here. We are using historical data from 2023, and using that data, we are trying to see what happened before the conflict. So if there were any ADSB GPS anomalies that happened before that conflict started, because if we can't find that, if that model works, it could be used in future in real time.
I was wondering if you could maybe elaborate a bit on what kind of data exactly you're analyzing, or what exactly your methods are. You were talking about gaps and jumps. Is that the way you're looking at the data to find jamming or spoofing, or do you have any other indicators that you're looking for specifically in the data?
Exactly. We call them jumps and gaps because we cannot 100% prove that those are jamming and spoofing. They are likely, but we don't have like 100% indication. Jamming event happens when we stop receive GPS data in ADSB packages for a certain period of time. So we filtered out very short jamming events. So if it happens more than 60 seconds, then it's significant, and then we would look at it and we would count it. And also we checked in ADSB messages, there is indication when GPS last GPS update, when it happened. So we only look at the messages that had recent GPS update.